this problem. It's the function f of x equals x squared minus 7x plus 10. So it asks us to use our own reasoning to make a sketch of this graph and then to find a few pieces of information, a few key features of the graph. Okay, now, right away we can look at the equation, and since it is given as the equation x squared minus 7x plus 10, that x squared term lets us know that this is a quadratic function. And quadratic functions always have that form of ax squared plus bx plus c. Sometimes you may not have the individual x term or the number term at the end, the c term, but you will always have an x squared term if it is a quadratic function. That's the giveaway. So when we're trying to do this, the easiest way to try and figure out a sketch of the graph is to find the key features. Some of them are a little tricky to find, or can be if you don't know some tricks as far as like factoring expressions or how to use the quadratic formula. But some of them are also very obvious. For instance, let's go ahead and look at the equation. When we look at this, we see the numerical term at the end. The constant term is just 10. That term right there is always the y-intercept of the graph. The number that is by itself, whether you're talking about a linear function or a quadratic function, those are always the y-intercepts, the starting values. So we already know that our y-intercept is when x is 0, our y is going to be 10. And if that doesn't really make sense to you, we'll just think about what happens if you plug 0 in for x. Okay, 0 squared is 0, that goes away. Minus 7 times 0, 7 times 0 is also 0. So you just have 0 minus 0 plus 10, you're going to end up with a y value of 10. Okay? Now, take the equation, x squared minus 7x plus 10. If you're able to factor your quadratic expression, then it makes solving this type of problem much simpler. So, what I want us to do is to look and think about what are the factors of our final number here, 10, that would add up to negative 7. And that will allow us to factor this expression into two linear terms, x plus or minus something, and then x plus or minus some other term. So factors of 10 that add up to negative 7. What numbers can you multiply to get 10? 1 times 10, 2 times 5. That's it. Now, we notice that the middle term is negative. If we use just positive numbers, there's no way we can add those up and get a negative value. So we realize if we want a positive when we multiply and a negative when we combine them and add them, we need two negative numbers each time. So which of these pairs is going to give us negative 7 when we combine them? Well, that's going to be these two, negative 2 and negative 5. So that means we have x minus 2 and x minus 5 as our expression. Notice these are not the values that we're saying x is equal to. These are the values that allow us to factor this expression into two terms, x minus 2 times x minus 5. Okay? Now, once we get it here, if we're talking about the x-intercepts of the graph, that's what we're doing at this step. We're trying to find the x-intercepts. And by factoring, you'll see the reason that is very useful. The x-intercepts on the graph are the points where it crosses the x-axis. Well, the x-axis is also known as the line y equals 0. Because if you think about it, every point on the x-axis has a y value of 0. So that means our output, our y, or our f of x value in this case, is going to need to be 0 if we're talking about the x-intercepts. So that means that if x minus 2 times x minus 5 is 0, either this whole part is 0, or x minus 5, this part is 0. Okay, because then you'll have 0 times something, which will give you 0, or this is 0 times something else, and that'll give you 0. So we can write x minus 2 equal to 0 and think about what would I plug in for x to get 0. So what minus 2 is 0? That's just 2. And over here, what would I plug in so that x minus 5 would give me 0? Our answer is x equals 5. So these are going to be our x-intercepts at 2 and 5. So when x is 2, y is 0, or when x is 5, y is 0. We could try that by plugging them back in. If some of this is unclear, just let's see if it makes sense. 2 squared is 4, minus 7 times 2, which is 14. So 4 minus 14 gives us negative 10. And if you have negative 10 and then turn around and add 10, you end back up with 0. Same thing is going to happen if we use 5. 5 squared is 25, minus 7 times 5, which is 35. So 25 minus 35, that's negative 10 again. Add 10 back, and you're back at 0. So both cases, if we plug in 2 or 5, we get 0 as our output on y value. So we have our two x-intercepts and our y-intercept. What I want to do at this point is go ahead and start graphing these key points. So I'm going to grab a different color here. I will put my x-intercepts at 2, 0, right here, and 5, 0. All right. So these are at 2, 0, and 5, 0. I'm going to write that really small. Okay. Now our y-intercept we can also plot, which is at 10, 0. Now again, I'm making a sketch of the graph. On your paper, you should have plenty of grid lines that you're able to actually draw this exact. So I want to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I want to have my y-intercept right here at 0, 10. Again, I want to label that point pretty small. Now, I know a few other things about my graph based on the equation. Since the x squared term is positive, since this is positive x squared, that tells me that this graph is going to open up. And by opening up, it's going to have the opening up shape. It's going to have the open U shape. Right. Again, that is because this x squared term was positive. So I know that my graph must come down like this and then turn and go back up. So I'm going to go ahead and draw this coming down to here, and then I know it's going to do the same thing on the other side. Now, I'm not going to draw this bottom part just yet because I don't know how low this point is going. So to figure that out, we use a little trick. Two ways you can think about this. The minimum and maximum, as we discussed in class when we were studying quadratics, is always halfway between the two x-intercepts. The x value of the minimum and maximum is always halfway between those two x-intercepts. So if it's halfway between 2 and 5, what number is halfway between 2 and 5? You may be able to do that in your head. If not, you can use a little trick. You always just add the two numbers and divide that by 2. That's the number right in the middle. So 2 plus 5 is 7, and half of 7, or 7 divided by 2, is 3.5. So that means the middle of my graph will be when x is 3.5. Okay. Now, to figure out what that value gives us, as far as where it's located along in the y direction, up and down, we would just plug it back into our original equation. So I would take 3.5 squared minus 7 times 3.5, and then go back and add 10. Okay? So I'm going to grab a calculator over here. I don't quite know my 3.5 times tables. So 3.5 squared gives me 12.25. Subtract 7 times 3.5, which gives you 24.5, and then turn around and add 10. And then we plug all that in once more. 12.25 minus 24.5 plus 10 gives me a y value of negative 2.25. So when x is equal to 3.5, we have a y of negative 2.25. So it's actually just a few places down on the graph. Between 2 and 3, a little closer to 2. It's going to come down, reach that point. I'm going to label it an x of 3.5 and a y of negative 2.25. And now I've used all the key features of the graph, and we have a pretty accurate sketch. Okay? So that's how you work these out. Again, don't forget to label your point here. X is 3.5, y is negative 2.25. You've got your x-intercepts, your y-intercept, your maximum minimum point. In this case, it was a minimum, seeing as how the graph opened up. And we have our graph complete.